can you express other angles between the angles of 0 and 360? So we're going to do this with degrees first, then we'll do radians, which is a little tougher. But in a circle, the Greeks said, we start at 0. This is 90. What would this be? 180. This would be 270. And this loops around to 360. Okay, now, what if you had an angle like 420? Well, on the circle, what that's going to do is it's going to go all the way 90, 180, 270, 360, and then it's going to go a little bit further. Okay? How would you know how much further it goes? What should you subtract? Yeah, just subtract 360. This is what we call, this is going to be, what is that, 60 degrees? It's going to make it up to 60 degrees. So which is a larger angle on the circle, 60 or 420? It's a trick question. They're the same, because what you're doing is you're saying, here's 60, and here is 420, but they both end up at the same place. So from what we call a reference angle of 0, 0 is always going to be here. And then if you sweep up 60, or if you go around 420, you're still going to end up at 60. 60 is what we call the terminal side. Okay, so here's your 45. Now we can do it in the, this is the positive direction, going this way. We can go in a negative direction too, and whenever you put a negative in front, then that's going to be in the negative direction. So if I said 60 here, like this, here's your 60, that's the same as a negative what? Any takers? 60, here's 60 degrees. That is from 0 up to here, 60. What is it on the negative direction? Negative what? Yeah, 300. How'd you get that? I just subtracted 360. That'll give you negative 300. Now, it seems bad that we're below, that we're at the negative, but it's not. It's just, it's the same place. That's the nice thing about a circle. Okay, so you can do all of these different things. Let's go to these right here. You try. We did this already. This is the same as negative 300, and then see if you can find it for these three. Go. See how you did for negative 225. This is in the negative direction, negative 225. What can you do to find out what it is in a positive direction? What could you do to negative 225 to find out what it is in a positive direction? What do you think, Elizabeth? Yeah, just take 360 and then subtract 225, and this is just going to be, let's see, is it 135? That sounds about right. So you can either have beta equal to negative 225 or positive 135. How many got that? 135? Good. So what did you do, Garrett, for this 3? You have 540. What should you do with 540? Well, yeah. Just subtract 360, because it's going to be one loop, right? And if you look at my picture here, you can kind of see this. It makes one loop, and then it goes, and then some. So if we do subtract that, you're going to get 180. So this will be pi, or it'll be 180 out here. Okay, so you have, for this one, you have gamma equal to 180. And we could also say gamma is equal to negative what? This is easy. Negative 180, right? Yeah. And this one here, you could add another 360, and you could say that this is going to be 495 degrees. You can just keep adding 360 forever. There's an infinite number that'll work. And then for this last one, negative 750, you're going in the negative direction, one loop. Looks like you're going to make a second loop, because what's two negative 360s? 720, right? So if you added 720, what do you get? Negative 30. Does that sound right? So phi here is going to be negative 30. And then if we added 360, this would also be what? Yeah, 330. Oh, you like the degrees, don't you? This is easy, right? So everything gets more interesting when we go to radians, okay? But no big deal. What did we add every time or subtract every time? What degrees? 360. So what's a whole loop in radians? Instead of 360, we're going to add what? How many pi's? 2 pi's. Okay, that's a complete circle. So if you take this alpha is pi over 6, one complete loop is 2 pi. How many pi over 6's is that? It's not hard. 2 times 6 is, there you go, 12. Yep. So with this, instead of adding and subtracting 360, you're going to add or subtract 12 pi over 6. How about this over 3? 2 pi is equal to how many pi over 3's? 6. How about pi over 4's? 2 pi is going to be equal to how many pi over 4's? 8. Yep. And how about pi over 2's? 4. So all you're going to do is add or subtract that denominator. The only difference is you have different denominators instead of always 360. Is that okay? You go ahead and find these then. Get the plus or minus on those. Number 1. Let me just do this number 1 here real quick. So you have alpha is equal to pi over 6. That's 30 degrees. So if we go in the opposite direction, you're going to subtract 12 pi over 6. And what's pi over 6 minus 12 pi over 6? What is that? Negative what? 11 pi over 6. Yep. So those are the two coterminal sides. If you wanted to, you could keep, subtracting 12, and you could get negative 23 pi over 6. And you could get negative 35 pi over 6. You just keep going forever and ever and ever. You could also add 12. Likewise, you can do something similar with these. So you try 2, 3, and 4. Beta and beta. Gamma and gamma. And phi and phi. Tell me, what did you get, Masha, what did you get for this one, the positive one? Just add 2 pi, right? Just like 360. So if you add 2 pi, how many pi over 3's is that? How many pi over 3's is 2 pi? 6, right? 6, that's 2 pi, right? So if I take negative 4 pi over 3 and add 6 pi over 3, what do we get? 2 pi over 3. You good with that? See what I did? Here's negative 4 pi over 3. And then we're going to go the other way and say this is 2 pi over 3. Does it kind of visually make sense? Yeah, because each pi over 3 is 60, so this is like 120. That looks like about 120 degrees. Okay, yeah. Mm-hmm. Oh, 3 pi over 3 is a half a circle. Remember how we did when we did the Skittles last week? Remember the Skittles? It was 1, 2, 3.14. Pi was half of the circle. And here's another way to think of it. This is not obvious, by the way. Everybody has this question. I like it a lot. This is going to be 2 pi. Let's say the radius of the circle is 1. What's the circumference of any circle? Any circle. 2 pi r, right? So if the radius is 1, what's the circumference? Does that help too? That's a second way to think of it. Yeah. Not obvious. Thank you for asking that. That's a great question. Okay. And it's on video. That's even better. All right. So then this one, we're going to subtract 2 pi. But this is how many pi over 4 if it's subtracting 2 pi? 8. So this is going to be 1 pi over 4. How many got 1 pi over 4 for that? That's the positive one. Now let's do the negative one, which is going to be negative how many pi's over 4 if we subtract another 8? Negative 7. So this is going to be pi over 4, and then this one's going to be negative 7 pi over 4. How are we doing? This isn't so obvious, is it? But it'll work. Let's go to the last one, negative 5 pi over 2. Now, 2 pi for this one was how many pi over 2? 2 or 4? 4, right? That's still 2 pi. Okay? So if we added 2 pi, you're going to get negative pi over 2. Add another 2 pi, what are you going to get? 3 pi over 2. Does that work with the picture? This is 3 pi over 2, and this is negative pi over 2. I think it works pretty well. That's real quickly, here's from the homework here, number 17. Here is 3 pi over 4, right here. Okay? So what is the negative going to be? I want a different color. Here we go. What's that going to be? Negative how many pi over 4? Well, we can get that by subtracting how many pi over 4? 8. So this will be negative what? 3 minus 8. There you go, negative 5 pi over 4. So it says here, classify each, where a terminal, then give 2 coterminal angles. One's positive and one's negative. Okay, so we got the negative one. Add 8 pi over 4. That'll give me 11 pi over 4. So here's your theta. And the other one will be 11 pi over 4. So now we have one positive and one negative. You do that for 18. Find a positive and a negative for this one.